Okay, we're solving an improper integral. This one goes from negative infinity to 0. It's z over z to the 4 plus 4. With this one, of course, like with any improper integral, we have to replace the limit with some variable and then let the limit approach the infinity, whether that's positive or negative. From t to 0, 0 is good because if we plug in 0, we still get a number in the denominator which is not 0. So with this one, we have to notice that we're going to have to use arctangent. We have z squared plus 4 dz. We're going to use arctangent because we have something squared plus something here, and there's a way to make this 1. There's a way to make this 1 and have this 1/4 just come out. Right now we don't have 1/4 in here. We can't just do that because this is being added and this is not being multiplied by 4. But there's a way to make a u substitution so that we do get a 4 since we're squaring this. So we're going to let u be z squared over 2. Z squared because that's what's inside being squared, and over 2 because that's the square root of 4. And since we're going to square it, that's a good idea when we make our u substitution. So du is z dz. Now we could go and make this substitution. Negative infinity from t to 0, we've got 1 over, what's z squared? We could solve for it. We've got 2u equals z squared. That's what we wanted. So we've got 2u squared plus 4 du. So now we had exactly what we wanted. Now we have 4u squared, and that allows us to use arctangent. 4u squared. Bring out the 1/4. 1/4. We go from t to 0, and here we just apply arctangent because we have the form that we needed. Limit as t approaches negative infinity. The form that we needed, this becomes automatically arctangent. Arctangent of u when we apply the integral to this thing that looks this way. And it's being multiplied by 1/4. And it's from t to 0 with the limit as t approaches negative infinity. So now what happens is we take the upper bound and subtract from that the lower bound. The upper bound gives us 1/4 arctan of 0 minus the lower bound, which is 1/4 arctan of t, because we're making that substitution, and we're having the limit as t approaches negative infinity of this entire thing. It really only matters on this side, so you could also just write it on this side. Minus the limit as t approaches negative infinity. Is this even visible? Yeah, okay. Now, what do we get? We get 0. Arctangent of 0 is 0. If you remember the graph of arctangent, it's just like tangent, but sideways. So it goes like this. Because remember, tangent was this, but the other way around. So with this horizontal asymptote is pi over 2. And this one is negative pi over 2. Negative pi over 2. So when we plug in 0, we get 0. When we plug in infinity, it just keeps getting closer and closer and closer to pi over 2. So that's what we get here. We're subtracting 1/4 times pi over 2, which gives us negative pi over 8 as our final answer.